So we'll be looking at the exponent laws or the laws of indices. Very, very interesting topic in mathematics, because indices, what indices does, it gives us the clear picture of how we use the whole idea of how we understand exponential growth with bacteria and all of that in the scientific realm. So indices actually tells us how do we work with exponents, and as you say, the laws of indices are the laws of exponent. So let's try to look at what is really an exponent. So if I have, let's say I have 3 raised to the power of 2. Now this is what we call an exponent. It is called a power. It is also called an index. In some equations, system of equations, they are called, like in quadratic or binomial equation expressions. We call them like degrees and so on. But we will be referring to them as powers, or we can say call them exponents. So what is this saying? This is telling us that this is dictating to the base. This is what we call a base number, and this is the exponent. So the exponent is dictating to the base number to actually have copies of itself in a repeat a certain amount of time, depending on what the exponent is. So if the exponent is actually 2, then the exponent is telling the base number to make a copy of itself twice, or in repeat 2. So what it does, it is now multiplying itself by itself, and that's basically the idea of exponents. So what the exponent does, it actually tells the base number to multiply itself by itself over a certain period of time. So if I had, let's say if I had so say if I had 3 raised to 3, so this is telling me I must have 3 times 3 times 3. So I must have 3 identical 3s being multiplied in repeat. So that's simple what exponent does. But there are some laws, because we have different forms of exponents and different conditions of exponents. So there are 6 laws that we'll be looking at in indices, or 6 laws of exponents that we're looking at. So the first law that we want to look at is the law that says the multiplication law. Multiplication law. And what does this mean? Now the multiplication law is very, very, very easy. It is saying if you have an expression or two, or you have some terms, say I have a multiply, let's say a squared multiplied by a raised to the 3rd power. Now if the bases are the same, then the multiplication law says we must take back one of the bases and we just add the exponent. So this will give us 5, a raised to the power of 5. So that's simply what it is saying. Or so we could even expand this. We could say this is actually what? A raised to the power of 2 is basically a times 3 identical a being multiplied. So a times a times a. And if you should, each variable has an exponent of 1. So if we should actually count how many exponents we have, we actually see we actually have 5. And since the bases are the same, we will just bring back one of the bases and add 1, 2, 3, 4, 5. And so it could be looked at in many ways. So let's look at the other law. Now this other law is called the division law. The division law. So the division law says, well, it's somewhat similar to the multiplication law, but there's a big difference. So the division law says if I'm dividing say I'm dividing 2 identical bases with different exponents. So what I would do, if the bases are the same, then I would take one of the bases and I would subtract the exponents. And so this will give me x raised to the power of 2. So let's look at 2 examples, multiplication and division law. So what if I had the x raised to the second power times 3 to the second power. Well, let's just say third power. If we should look at it, if they share the same variables, then we can actually, we can actually work them all together. So what we could do, we could actually multiply the coefficients, 3 times 6, and then since the bases are the same, we take back one of them and we'll just add the powers. So this will actually gives us 6 times a raised to the 5th power. And if we want to expand this term, we'll actually end up with the same thing. So, to save time, let's not do that. Let us look at the division. What if I had 10x raised to 4 divided by, let's say, 5x raised to, 5x. 5x. So what we'll do is, since they share the same base, the same variables, then what we'll do, we can actually divide these coefficients and we get 2. And since the variables are the same, or the base in this are the same, we'll just subtract the powers. But this term has an exponent of 1. So we have 4 minus 1, which is the same thing as 2 raised to the 3rd. Well, it could be left in this way since we're dealing with exponents. But if we were to simplify this would give us 8. And so 8 is the same thing as 2 raised to the power of 3 in an exponent form. So let's look at the other laws. Now there's a law that says, this is the third law, law number 3. It says, anything raised to the 0 power is equal to 1. So let us prove this. We can actually prove this. So let's see. If I have, say I have 2 identical terms being divided by each other. Let's just work this out. We are dividing. So since they have the same bases, we actually take back one of the bases and we subtract the powers. And also if we have this, we have a raised to the 0 power. Cool. But let us look at this in regular mathematics. If I should say 2 divided by 2, I'm actually dividing 2 identical terms, 2 identical numbers. This will give me 1. So if I should divide any 2 identical terms, it will actually give me 1. If I divide a million by a million, I will get back 1. So if this gives us a raised to the 0 power, it's the same thing as 1. So we could actually rewrite that. So if I could just say this is also equal to 1 on the left hand side. So I could just ignore this and rewrite this as any way I want. Whether you want to write it like this, raised to that, or you want to write it like this, is equal to 1. It doesn't matter. So that's what the law says. Anything that raised to the power of 0 equals to 1, because there will be 2 identical terms dividing themselves. And so the powers will be subtracted and give you 0. So that's the third law. So we're looking at another law that is called power of power rule. So what it simply means is saying if I have a term and it is being raised to an index and this exponent form is being raised to another exponent, what is saying that these 2 exponents will actually multiply. That's what it is saying. But let us prove if this is so. We can prove it. We could use actual numbers to see if this is true. We could say, let us look at this. We could say, if I have, let's say, a raised to the second power raised to 2. Now, if we should go back to when we were actually, when this was introduced to us, if we had 3 raised to 2, this is actually that's 3 times 3. And so what this is saying I must have a times 2 times 2. That's what this is actually telling me. And if the bases are the same, I could actually just take back one of the bases and just add the powers. So my answer will be a raised to the fourth. And by just a shortcut, we could just simply just do that right here by a shortcut. So the powers will be multiplying. So we have a raised to 2 times 2 gives us 4. And that's what it is saying. So anything that is, so this is called the power of power rule. We could look at another example. If we had, let's say we have 2a raised to the third. And if we say, let's say, or let me just change this and just have a square and we say 3. Now we could work, no, this is saying that this is the power will multiply the power, or would actually, you could actually expand this to see if it makes sense. So what will take? The thing is that if you take it, if you look at it, even this has an exponent right there. So what we could actually do is, so if this is an exponent here, so we could multiply that by 3 and multiply that by 3. So what we will have is this 2 raised to the third, well, 2 raised to the third times a raised to the, a raised to what? 2 times 3, or if you want to say this times 1, because it has an exponent of 1. And so we'll go, we'll say now, we'll say 8, we'll say now this time that give us 2 to the third, and this will give us to the 6. If we should continue working this out, we get 8 raised to 8 to the 6. And if you don't think this makes any sense, let us try to do it the way that it tells us to do it. So let us look at this another way. We could just actually, we could just have some copies of this. So what this is saying to us that we should have 3 of these being multiplied. So we have 2a square times 2a square times 2a square. And if you should basically follow the multiplication rule, we'll actually see what is coming out. Since the bases are the same, what we could actually do, since we have the coefficients are the same, so we could just multiply these. So it's 2 times 2 is 4, and 2 times 2 times 2 is 4, and 4 2s gives us 8. And since the bases are the same, we just take back 1 and we just add the power. So we have 2 plus 2 plus 2 gives us 6. And so we will actually have the same thing. Let's look at rule number. So it's a power. So let's look at this now. So we say power of a fraction rule. This is one of the laws that, you know, this is one of the laws that gives students a little challenge, because it sometimes can be very, you know, in terms of spatially thinking about it or abstractly thinking about it, you know, they are not actually seeing the picture. It's a power of a fraction. So what is really happening is this. Let us look at it. If you have a divided by b and it's being raised, so this is a fraction. This is a fraction. No, this is not a product. This is a fraction in the bracket raised to an exponent. What this is saying that this exponent will be distributed to each term in the bracket. So you have the a raised to the power of x and b raised to the power of x, and it's just simple. That's simple. So if we had this as the origin, we could actually rewrite it as that. So you could go on other side of the equation. That is one example. So if I have 4 over 2 raised to 2, this is simply saying that this 4 is raised to that, 2 raised to that. So we have 16 over 4 is equal to 4. Or if you want to rewrite this in exponent form, we could say what number multiplied by itself to get 4. So it would be 2 raised to 2. So we could even have that for answer over 4. It doesn't matter. So that's what it is saying. It is actually distributing itself to each term in the bracket. So let's look at the other law. So we're looking at negative exponents. Negative x negative exponent. So look at negative exponent. It's just always saying that we have base numbers that carry base numbers that carry negative powers or exponent with them. So it is saying that if I have a base number and it is being raised by a negative exponent, so what we will do, this will becomes a fraction. So what we do, we just take the exponent and put it as an exponent in the to the base number. I will just create a fraction. So if we had, what if we had b that to write this in an exponential form or exponent form, what we actually have is b raised to negative a. So whenever you have a negative exponent, it will actually give us a fraction. So what really happens? The exponent will be a new exponent. It'll be an exponent to the base number, and the base number will become a denominator as a fraction, and you just put 1 over it. So we'll have the base being raised by the exponent, and the exponent is going to be changed to a positive. But if you should write back the exponent, this form, if you should write back this form in an exponent form, then the power that you have, or the exponent you have, that will become a negative. So let us look at an example. Very, very simple. So if I have 5 raised to negative 2, what this is saying, I'll write back my base number as a denominator, and I will take this exponent and it becomes a positive, and I will create a 1. And so my answer will be 1 over 25, because 5 raised to the second power is 25. If I had, let's say, what if I had 1 over 4? Now, if I could rewrite this in an exponent form. What I could do, I could ask myself, what number do I multiply by itself to get 4? So if 2 would be the answer, so what I would do, I would actually let's say I would just have my 1, and I would just change this to an exponent form. And if I should write this now in where it is coming from originally, then I will be having 2 raised to negative 2. And if I should look at this will actually give me back this and goes back to that. So it's always you can actually move from one point to the next point, and it brings it back to the same place. So we're looking at the last law. And the last law is what? Fractional exponent. So we'll have a fraction for our exponent. And sometimes students confuse themselves with the one that we just did and this one. Now, the one that we just did is not a fractional exponent. It is a negative exponent. And so from a negative exponent, it actually creates a fraction. With the exponent becomes a positive while it is raised from a base number. And then you create a fraction above that exponent form. So it's greater 1. But this now is what? The power itself is a fraction. So it looks like this. So it looks like this, a fraction. It doesn't matter. You could say b x over y. So the exponent itself is a fraction. And so this is actually equal to what we'll normally do. We will take the denominator of the exponent, and we will create a root with it. And then we take the base, we write the base number there, we keep the base number under the root, and the numerator will become an exponent. So so let us look at it. Let us use numbers, for example, to see how this works. So if I had, let's say I had, if I had 8, and I had 3 over 2. or we could just say 1 over 2. Let's say a half. Let's say a half. Let's say a half. So what we will do, take the denominator of the exponent, and then we will create a square root. Take back the base number, and this 1 would become the exponent to the base number. And if we should simplify this, what we will get, well, this can't really simplify that, because we really don't have a square root of this. Well, we can find a value for it, but it would be so much complicated. So let's look at an example that we can actually use some simpler numbers. But this will be your answer. All right, so let me think. So we have 16. So we have 16 raised to, let's say, 3 over 2. Now what we will do with a square root, we have 16 raised to 3. Now we could actually, well, it doesn't really matter what you, well, let me see, well, it doesn't matter how you want to do it, whether you want to do the exponent first, or you want to find the square root. It doesn't matter which one you want to do. So if I want to find the square root of 16 first, then I will get 4 raised to 3 and 4, and they will give me 64. So, but if I want to work on the exponent first and then find the square root of that, then we could actually get the same answer. So let us do that just the same. So let us do the exponent part first. So if we do the exponent part, let us see what we'll have. So if I have 16 times 16 times 16, I think this give you 4,000, I think 96. So to find the square root of this will actually give you back 64. It doesn't matter which way you want. So that's basically the fractional rule. So let us recap on what we did. The first rule that we look at is a multiplication rule. Once the bases are the same, carry the base, carry one of the bases, add the powers. If it's division, carry the bases, subtract the powers. So look at the exponent, the power rule, the negative law, anything raised to power equal, anything raised to 0 equal to 1, the fractional rule, the product of the power rule, and there you have it. So I'll be doing some working out in another video, so you can actually watch that video that is coming up.